Okay.
Okay, thank you. Okay, so Peter said that we have 4 collision domain and 8 broadcast domain. And Pamela said that we have 9 collision domain and 5 broadcast domain. Whoa. Okay. So now let us count together. Okay, this is a switch. Okay, don't forget that the number of broadcast domain and collision domain depend on the type of device that we have. So let's start with the collision. Let's start with the collision domain. So when it comes to the collision domain, I remember during the last session that I said that each port of the switch belongs to one or represent one collision domain, because if there is a collision domain that occurs, only the port of the switch once the port of the switch will be affected by that collision domain. And here you can see we have one. Here we have one. Right now we have what? We have one, two, three, four switches, and we only have one hub. This is a hub. This device here, which is a hub. So now, and then I remember that last time, in order to find, I remember that I told you last time that in order to find those collision domain and broadcast domain, you can assume or you can imagine that there is something going on over the network topology. Okay, for instance, when it comes to the collision domain, you can imagine, for instance, that if there is a collision, this is a hub here. If there is a collision on the hub, that collision will impact what? What are the interfaces of the hub, or what are the interfaces of the switches around that will be affected or impacted by that collision which is occurring? Okay, so now when it comes to the hub here, you can see that if there is a collision that occur on the hub, all the port of the hub here will be affected. That's why I remember that I said that all the port of the hubs belongs to one collision domain, or the hub itself represent one collision domain. Okay, so now the hub, when there is a collision that occur on the hub, it will generate a bad signal, and that bad signal will go through those cables that are there, and it will impact the port of the port of the port of the switch, the switches that are around. So it means that this interface of the switch will be impacted by that, by what? By the collision. This one too, this one too, and this one too. But it is the same collision which happened or which occurred on the hub here. The same collision which is impacting the switch 1 port, switch 2 port, switch 3 port, and switch 4 ports. Okay, so it means that this is a collision domain. This is only one collision domain, the same collision domain. Okay, that collision that occurred on the switch is impacting the 4 interfaces on the different switches that are there. Okay, this is only one collision domain that we have here. I hope it is clear enough. Okay, so right now, if you have to count, we only have, we have only what? We only have one collision domain. Here we only have one collision domain. Okay, so now when it comes to the switch, so this is the collision domain. So now when it comes to the switch, to the broadcast domain, okay, sorry, when it comes to the broadcast domain, okay, so now regarding the broadcast domain, I said that imagine that if, for instance, there were a device. Okay, if just imagine, for instance, if there were a device that was there, and that device decided to send a broadcast message, and if that broadcast message is received by the switch here, what will happen? The switch will understand that it's a broadcast message, because I told you that the broadcast message is a message which is sent, is from one to everyone in the network. So when the switch will receive that broadcast message, it will be send it to all the devices that are connected to it. So it will send it to the what? To the hub here. The hub is a big idiot. Okay, so what the hub will do with that broadcast domain that you're receiving, it will take it and send it to all the devices that are interconnected, meaning that the broadcast message will be sent here, and sent here. Okay, and then what we can assume that, okay, we can assume that this is also what? This is also what? A broadcast domain, because the same broadcast message that have been sent, okay, the same broadcast message that have been sent by this device which is here have been received by all the switches that are there in the network topology. So we can assume that here we have what? We only have one broadcast domain, but not in between here. Basically, what I wanted to say that, okay, let me draw it correctly. So basically here we have what the message will be sent here like this, like this, like this. We can just consider all this to be one broadcast domain, because don't forget that last time I also said that the switches and hubs are just used to extend networks. Okay, so if they are used to extend networks, so it means that it's the same network which is there, that we are just extending by using more switches or more hubs. So and then I said that a network is also is equal to a broadcast domain. So that's why here you can see that based on those facts, we can see that here we only have what, one broadcast domain. So here we only have one broadcast domain. I don't know how you guys are counting those things, but here, okay. So Peter, please, how did you find the 8 and the 4 collision domain? So the 4 collision domain, I can understand, okay, that you counted each port of the switch here to be one collision domain. Yes, that this one I can understand, because most of the time students used to make these mistakes. But when it comes to the broadcast domain, how did you find the 8?
So I was confused. I was assuming that the broadcast domain is the point where occur the signal between each point of switch and the hub. I just count the different points, the point of the switch and the point of the hub, and I counting assume the 8. That's why I say 8 for the broadcaster.
Okay, yes, okay, I see. But now you have to take in account the fact that when the collision occurs, the collision will not only affect the will not only affect this interface of the interface of the hub here, but you also have to take in account the fact that a bad signal will be generated from that collision, and that bad signal can impact the devices that are around, okay, that are connected to what, to the hub. So if that bad signal, it's like the collision is trying to extend or to expand to the other device that are there, but fortunately those devices will be able to contain that collision effect on those ports only. You understand? The switches will contain those collision domain on their ports like this. Okay, so the collision effect or the collision impact will not spread out. Okay, it will not go far away over the network, if I can say it that way. Okay, so this is how we can count it. So let us move to the next one. Okay, good. So let us move to the next one. So this is the next topology. So here, okay, here now. So here, how many collision domain? Okay, so here now we have a router. So how many collision domain and broadcast domain do we have here? Okay, I think I started with Peter, so now I will start with Pamela.
Collision domain. One. 2, 3, 4. 4 collision domain.
Okay, so 4 collision domain, broadcast domain.
Broadcast domain. 2.
2 broadcast domain. Okay.
Yeah.
Peter.
Yes, sir.
Yeah, I'm listening. How many collision domain?
Collision domain. collision domain 2, broadcast domain 3.
Collision domain 2. 2 broadcast
Yes, sir.
domain.
Sorry. Okay, sorry, sir. Collision domain 1, broadcast domain 2.
Collision domain 1, broadcast domain 2.
Yes, sir.
There is something fishy here. I don't know if I'm the one, but there is something really fishy here because I don't really understand how you guys can counting this. Or should I come again about it? Because right now I'm confused. Okay, no problem. So let us count them. Okay. So now here we have, okay, let us count the collision domain and broadcast domain. So let's start with the collision domain. So here I have a switch. This is a switch. This is one switch. Okay, this is a switch, and this is also a switch. This one is a hub, and this one is a switch. Okay, and then when it comes to the switch, I told you that each interface of the switch, each interface or each port of the switch belongs to one collision domain. So let's start down here. Okay, you can see that here we have PCA, which is here. If there is a collision that occurs here on this link here, the collision will impact this interface of the switch. So this interface of the switch belongs to one collision domain. So with this one collision domain. So this one too, if there is a collision that occurred here, this one too belongs to one collision domain. That which proves the fact that each interface of the switch belongs to one collision domain. Okay, this one here we have two collision domain. So now this interface of the switch too, which is here. Okay, so you can see that here in between this switch and this switch which is here, we have the hub. So if there is a collision that occurred on the hub here, the collision will create what? A bad signal. We generate a bad signal that will spread like this. That will spread to all the devices that are connected to the hub. So now the switch here, when receiving that collision signal, will contain the signal here, and this switch too will contain the signal here. So we can say that here we have one collision domain which is also there, another one. So now we have this switch which is here, where we have device F and E that are connected to this switch. So each interface of the switch belongs to one collision domain. So this is one collision domain which is here, and this is another collision domain which is here. So let's start with the other switch which is here. So this switch here, between the two switches here, if there is a collision that occurs here, this interface will be impacted, this one too will be impacted. Both will be impacted by the same collision, so we consider that those two interfaces belongs to the same collision domain. So between the switch and the router, okay, if there is a collision that occurred here, so the collision will impact this interface of the switch and this interface of the router. So they are impacted by the same collision domain. Let me say it again. They are impacted by the same collision. Okay, so both interface, the interface of the switch and the router interface belongs to the same collision domain. Okay, because it is the same collision which is impacting both ports. So now we can count now. So we find all the collision domain of this topology, so we can count them. So here we have one collision domain, the second one, the third one, the fourth one, the fifth one, the sixth one, and the seventh one. So right now we have 7 collision domain. Okay, so now let us move to the broadcast domain. Okay, so now when it comes to the broadcast domain, let's imagine that PCA here is sending a broadcast message, because what defines a broadcast domain is a broadcast message, the scope of the broadcast message. Okay, So now, when the switch will receive that broadcast message here, it's a broadcast message is intended to everyone. So the switch will send it to all the devices that are connected to it. It will send it like this, it will send it like this, it will send it like this. But now, when the switch at the top here will receive it, you also send it to all the devices, you will send it to the router here, but the router will contain that broadcast domain on this interface, or will block that broadcast domain on this interface, because I told you last time that the router do not forward the broadcast messages. So now, the broadcast message will make it to the hub here. The hub is a very big idiot. This one I used to say it a lot. Okay, so what is going to do with that broadcast message? It will send it to all the devices that are connected to it. So we send it like this, it will send it like this, and you will also send it to the other switch which is here. So the other switch, when you will receive it, you will understand that it's a broadcast message, the same broadcast message that have been sent by PCA. And this switch will also do what? Will send it to all the devices that are connected to him. You will send it like this, and you will also send it like this. So it means that the same broadcast message sent by PCA, okay, was able to be received by all the devices that are there. So we can decide, we can say that, okay, all those devices, okay, belongs to the same broadcast domain, because that broadcast message covers all this whole area. You understand? So now we can say that here, all this, okay, is what is the same broadcast domain. And you remember that I also said that each interface of the router represent a broadcast domain. So right now we only have one interface on the router here, so, which is connected to the subnet, to the switches down here. So we can say that this interface of the switch which is here is what is a broadcast domain. Do you understand? So right now we only have one broadcast domain and 7 collision domain, which is way different regarding what you guys found. Yes, Pamela.
Okay, so the explanation it seems to be different each time, or maybe I'm not getting it, because from what you explained right now, that this whole the entire network is one broadcast domain. How about assuming B also sends something?
Yeah, let's assume then.
And C also sends concurrently.
Yeah, no, is regardless. I mean, the broadcast message here is regardless to any device. Okay, whatever the device that will send the broadcast message, that broadcast message, how far it will go in the network. This is the question. You understand? Even if I change the device here, let's say that maybe I decided to take another device. Okay, I'm just taking the example based on one device. So one, let's say I'm saying that PCA is sending, but it could be, for instance, PCB, which is sending the broadcast message. Okay, let me take PCC for instance. If PCC is sending a broadcast message, what will happen to that broadcast message? How far this broadcast message will go in the network? Because I remember that I said that the definition of the broadcast domain says what? So the broadcast domain is the scope of the broadcast message. Okay, it is also defined as the area that the broadcast message can cover regarding the devices that can receive, that will be able to receive the broadcast message in the network. So now the PCC is sending a broadcast message. That broadcast message, when it will come to be received by the hub will do what with that broadcast message? Depending on it, the default behavior. You know how the hub works, right? It will do what with that message? It will just send it to everybody. By sending it to everybody means that you will send it to this switch here, it will send it to the PCG here, it will send it to the other switch here. Do you understand? But now this switch which is here on the right side, when you will receive that broadcast message here, what is it going to do with that broadcast message? You also send it to all the devices, because the broadcast message is a one to everyone message in the network. So when the switch receives a broadcast message, the behavior that you will have is to just take that message and send it to all the devices so that they can receive it, because it is a broadcast message. It should be broadcasted to all the devices in the network. All the devices should be able to receive it. So this switch will do what? It will send it to PCE, it will send it to F here. But this switch also, which is here, it will also receive that same broadcast message. What is it going to do with that broadcast message? Because it is a broadcast message, it will send it to everybody. It will send it to B here, it will send it to A here, it will send it to the switch at the top. The switch at the top will do what with that broadcast message that he is receiving? It will send it to what? To other device, to the router which is at the top. And the router, because the router do not forward broadcast messages, the router will block that message here. And you can notice that the broadcast messages have been received by all the devices in the network topology. So we can say that all the devices right now are in the same broadcast domain. Let me take an example. This one I think will be a great example. Imagine you are imagine that you are in a classroom, and in the classroom there are 50 students. So when the trainer is speaking, everybody in that classroom should be able to hear or to listen what the trainer is saying. Are you on the same page? Pamela, are you there?
Yes, please.
So if there's a let's say there's a trainer in a classroom and he's speaking, in this classroom there is 50 students. So all the 50 students normally should be able to hear what the trainer is saying or what the trainer is teaching. At that time, the voice of the trainer is able to make it to all the ears of the student ears, and they are able to listen to what he is saying. So we can say that his voice is broadcasted to all the students that are in the classroom. But now imagine that classroom, there are some of the students, okay, that are outside. They are not in the classroom, but they are outside. So what the trainer is saying inside, because they are outside, they cannot hear it, because maybe let's say that the door is closed, the classroom door is closed. It means that if you are outside the class and you are not able to listen to what the trainer is teaching inside the classroom, it means that you are not in that domain. Okay, so all the students that are in the classroom, we can consider them in the same domain, because they are able to receive the same teaching from the trainer, which is in the same classroom. Because of the fact that you are outside, you are not listening, you are not hearing the same thing as the one that are in the classroom. You are not in the domain. You are not in their domain. So I can explain it that way. So right now, the same message have been received in this topology by all the devices that are present. The same broadcast message. Okay? So that's why we can consider that all the devices that are here, that in one broadcast domain. It's a domain, and which is represented by the fact that all the devices are receiving the same thing.
Okay, with that understanding, let's go back to one and see if I'll get it this time.
Okay. So now, okay. So let me clear it. Okay, so now let's go to this one which is here. This is another one. So please pay attention. Okay. It also depends on the device that are there and the device that are present here. Right now we have routers that are there, we have switches, and we have a hub. So based on the type of devices that are here, and you imagine, okay, if it's a collision domain, if you are looking for collision domain, imagine that there is a collision that occurred, in order that it will help you to find the collision domains. But if it is a broadcast, you are looking for broadcast domain, imagine that there is a broadcast message that have been sent by any device in the network, and what will happen, how this broadcast message will go, how far this broadcast message will go in the network, and it will help you to find the broadcast domain. So we have another one here.
Okay, I'll attempt the broadcast domain.
Okay.
So if PCD is sending a broadcast domain, it will send it to the switch. Sorry, it's a hub. Okay, let me start from PCA.
Okay.
PCA, if it's sending a broadcast, it will send it to the switch.
Okay.
All the interfaces of the switch. When it comes to port B, we'll send it to port B, send it to the switch up there. The switch will also come down and send it to the hub.
Okay.
and then push it to C and D, and then send it up as well to the router.
Okay.
Send it to the, but the router will cut it because it doesn't forward broadcast message.
Okay. Therefore,
So that whole so right from that interface where the router is coming down will be one broadcast domain.
that's it. You got it right.
Yes. So this whole place will be one broadcast domain.
Yes.
Okay. So between the first router and the middle router, assuming there's a switch between them and there's a broadcast,
Okay.
it will go to the router to the left and to the right.
Okay.
So that's one broadcast domain.
Okay. This is another broadcast domain.
Yes, and then the other side will also be another broadcast domain.
Okay. So how many broadcast domain do we have in total?
So 3.
Thank you. You got it right now. So the word
But the collision, I still don't understand. So you have to go over the collision again.
Okay.
Okay.
Okay. So for when it comes to the broadcast domain right now, we have 3 broadcast domain here, because you can, and then something that can help you to find those broadcast domain fast is also the fact that each interface of the router here belongs to one broadcast domain. So just looking at, for instance, at the router in between the which is in between this router, which is in between those two here. Okay, you can understand that, okay, this interface here belongs to one broadcast domain, this one to one broadcast domain, and this one too is one. Automatically you found what? The 3. Okay, without wasting too much time. Okay, so now when it comes to the collision domain, so broadcast domain, we have 3. Collision domain. So when it comes to the collision domain, as I said, you just have to look at just have to assume that there is a collision that occurred. It will help you to find the collision domain. So now, concerning the collision domain, Pamela, do you want to go again?
No, you go over the collision domain, please.
Okay, so concerning the collision domain, as I said, here we have a hub. If a collision occurred on the hub here, okay, what will happen? All the interface of the hub here will be impacted, and the hub will generate a bad signal, which will impact all the devices that are connected here. You understand? So all the hub here itself represent one collision domain. But now when the bad signal that will be generated by the hub because there is a collision that occurred, that collision will spread and will expand and impact this interface of the switch here. Okay, but the interface of the switch is able to contain that effect, that collision impact. So it means that this one here is only one collision domain, and the statement says that one interface of the switch, each interface of the switch belongs to what? To one collision domain. Are we okay? So now let's come back to the switch which is down here. Here we have a PCA which is connected to the switch. If there is a collision that occurred here on this link here, that collision will impact the PCA. It will also impact this interface of the switch. So this interface of the switch here belongs to one collision domain. This interface of the switch here also belongs to one collision domain. Are you okay? So now the interface which is up here, okay, also belongs to one collision domain. Why? Because if there is a collision here, that collision will impact this interface of the switch, but it will also impact this interface of the switch. So both interfaces here belongs to the same collision domain, because they are impacted by the same collision. So we can see that this one too, they belongs to one collision domain. Are you okay? So at the top here, this interface and this interface here, if there's a collision that occurred on this link, okay, it will impact both interfaces. So we can say that those two here, they belongs to one collision domain, the same collision domain. The same thing with the routers here. Between the routers, if there's a hub, let's imagine that there is a hub, for instance, between the two routers here, and there's a collision occurring on the hub, it will impact this interface of the router and this interface of the router. Are you okay? So it means that those two router interfaces belongs to what? To one collision domain. And here too, those two router interfaces belong to what? To the one collision domain. So how many collision domain do we have? We have 1, 2, 3, 4, 5, 6, 7. 7 collision domain and 3 broadcast domain. Is it clear enough?
Yes, please.
Okay. So now I think, as I said, okay, let me just clear this first. So we have done this one, we have done this one, we have done this one. Okay, so this will be our last one that we do, and then we'll move on to our new topic. Okay, so this one. Okay, let us find the broadcast domain and the collision domain. So how many broadcast domain and collision domain do we have?
So two broadcast domain.
2 broadcast domain, collision domain. What about the collision domain?
Seven.
7 collision domain. Okay, let us count. So in order to go straight to the point, when it comes to the collision, the broadcast domain, as I said, you can just look at, if there's a router, you can look at the router directly. The router has 2 interfaces where there are devices that are connected. We can assume that we have two broadcast domain directly. So this is one broadcast domain, because if there's a broadcast message which is sent here, the hub and the switches here, they will do what? They will just send it to everybody. Okay, but now when the message will make it to the router here, the router will block that broadcast message here. So this is one broadcast domain. The same thing for this side. Okay, so 2 broadcast domain is correct. Are we okay? So now okay, so now when it comes to the collision domain, how many collision domain do we have? Each interface of the switch belongs to one collision domain. So this interface of the switch is one collision domain, this one too, and this one too is one collision domain. They belong to the same collision domain. So this is a hub. The hub, all the hub here, the interface of the hub belongs to one collision domain. This interface here also belongs to the same collision domain here. So we can say that here we have one collision domain here, and here also we have one collision domain here. Between the switch and the router here we have one collision domain here. Between the router and the switch here we have one collision domain here. Between the switch here and this is a hub. So if there is a collision that occurred on this hub, the collision will generate a bad signal. It will get to this hub. The hub here will receive that bad signal and it will do what? Because it's a very big idiot, it will just generate that bad signal. So it will impact the devices here. So this second hub will be impacted by the same bad collision. This device here will be also impacted by the collision, but the collision will be contained by this interface of the switch. So we can say that here we have one collision domain. Are we okay? So how many collision domain we have? We have 1, 2, 3, 4, 5, 6, 7. And Pamela, you got it right. Okay? So this is how we found the collision domain, the broadcast domain. I hope now everything is clear. Are we okay?
Yes, please.
Okay, so now those questions that are really important, okay, I'm really emphasizing on it because you may come across such questions during the international exam. Okay, they can ask you some question about, okay, they will give you a topology like this, and then they will ask you, okay, how many collision domain do you have, and then you have to find those collision domain and broadcast domain. Okay, so you have to master it. So now what we are going to do, we are going to start our new topic. Okay, so now concerning this file, okay, as I said, we did the four, okay, we did four topologies, so it remains four. Okay, the four remaining topology that are there, this one, okay, and this one too. Okay, I'll upload the file in the drive so that, okay, you'll be able to have it. You have it, and then you can practice on finding what the broadcast domains and collision domains. Okay, I'll upload the file in the drive for you to practice. Okay, so now let us start our new topic. Okay, but now concerning our new topic, basically what we are going to do, we just go, I've prepared everything. So let me just take the file because I don't want us to waste time. Okay, okay, so concerning our new topic, what we are going to do, we'll go through this file. Okay, so basically what we are going to do, we'll go through these files and I will be explaining everything. So our new topic, our today's topic will be about what we call addresses. So today we are going to talk about addresses. Okay, but now let us discuss more. You know, in real life, if for instance you want to send a letter to someone, okay, let's say that you are in Accra and you have maybe your let's say that your girlfriend, okay, she is in Kumasi and you want to send your girlfriend a letter. Okay, so now you write the letter, okay, on the white paper and everything, and you will take that letter, you put it in the envelope. But now when you finish writing the letter and putting it in the envelope, okay, on the top, or let's say that you take the letter, you put it in the envelope. Okay, now at the top of the envelope you have to precise some information so that when you go, you go and give the letter to the postal service, okay, for them to deliver it. Okay, they will make use of those information you put on top of the letter to deliver your letter. Okay, and this is the normal process. Okay, so basically you write take the letter, put it in this envelope, and then on top of the envelope here you maybe say that, okay, to my dear girlfriend, and then you put a number, you put a house address. Okay, so that now when you go and when you post the letter, okay, the postal service guy will come and pick it up, and then based on those information that you put on top of the letter, the postal service will know where to deliver the letter, and to which house exactly. Okay, so what is giving the postal service the capability to deliver your letter to the right person, okay, to your girlfriend, is the information that you put on the letter here. So it means that those information that are really important, okay, they are really important, okay, because it's based on those information that we will know how to deliver the message to the right person. Are you okay? So now those information, they are basically the name of the person, they are some addresses. Are we okay? So now devices, when we have for instance a switch, okay, and to this switch we have devices that are interconnected like this. Okay, we have maybe here PC A, PC B, PC C, and PC D, and let's say that maybe PC A wants to communicate with PC D, for instance. Each of those PC here, when you interconnect them like this to the switch, they don't have any idea, or they don't have any information concerning the devices that are also connected to the same network. By default, if there is no communication that has occurred before, each of the devices here do not have any information or any idea of the other device that are interconnected to the network. But now if PC A here wants to communicate with PC D, PC A also wants to make use of some information, okay, that you will need, okay, in order to locate where the destination device is. Our destination device here is PC D. So if PC A wants to communicate with PC D, PC A should know what is the name of PC A and where is PC D is. Okay, PC A should have to know the name of PCD and where he is located in this network. Okay, and it is only at that moment that PCA will be able to send the message to PCD. Are you okay? So now it means that PCA needs some information, and the information that PCA needs, they are what we call addresses. So in networking, devices make use of addresses in order to locate other devices in the specific network. The same way with the later case that I have just given. Okay, because PCA wants to make sure that when he will be sending that message, the right device will receive it, the device PCD. Okay, so in order to make sure that it is PCD that will receive that message, it should have the information concerning PCD. Is it clear enough?
Yes.
Okay, so now basically what we are going to see today, we are going to talk about what are those addresses that the devices in the network uses in order to communicate with other devices in the network. Okay, so now before talking about those addresses, let us talk about some small concept that we need in order for us to be able to understand the rest of the word of the topic. So before talking about those addresses, let us talk about some small things. Okay, so now the first thing that we talked about is what we call a bit. Okay, so now a bit, okay, a bit here it is here a bit. So a bit is the most basic, as you can read here, a bit is the most basic or the smallest unit of information that a computer can process and store. So a bit is considered to be the most basic or smallest unit of information that a computer can store or process. Are you okay? So now we have what we call a digit. Digit, they are just single numbers, okay, used to represent values in mathematics. For instance, if you want to write down, for instance, 15, 1 here is a digit, 5 here is a digit. So we have digits that start from 0 up to 9, and then mixing those digits, we can create some values. Okay, for instance, 15 here. Okay, so when it comes to the 0 here, we can consider it as a digit. 1, 2, 3, 4, 5, 6, 7, 8, 9. We can consider them as digits. Okay, in networking we consider them as digits. Okay, so now the next thing that we will look at is what we call the different types of numbering system that exist in the world. Okay, so we have different types of numbering system that exist in the world. Okay, we have what we call the decimal numbering system, and the decimal numbering system, this is the numbering system that we human we use the most, because when we are making calculation and everything, you want to count money, and then we use the decimal numbering system. This is the one that we human we use the most. Okay, and the decimal numbering system, sometimes we used to call it base 10 numbering system. Okay, or base 10 numbers. So there are numbers from 0 up to the decimal number system is let's say made of 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers. So we are from 0 up to 9. This is the decimal numbering system, and this is the one that we human we use. Then we have another numbering system that we call the binary numbering system. We also call it the base 2 numbering system, which is only made of 2 values or 2 numbers, so 0 and 1, and this is what we call the binary numbering system. But now we also have, when it comes to the binary numbering system, this is the one which is used by computer system. Okay, so computer systems, okay, or computers okay, make use of the binary numbering system. So when you are for instance, on your keyboard, okay, you are on your laptop and you are typing on your keyboard, okay, you know that keyboards, they are made of the keys on the keyboard, they are made of the letters and everything. So when you are typing let's say a key on your keyboard, you are inputting letters basically, but now the computer do not understand the letters that you are inputting by typing on the keyboard. The computer do not understand that. The computer will do what? The computer will convert the letters that you are inputting by typing on the keyboard by what we call the binary, and this is only the binary values that the computer understands, which is made of 0 and 1. Are you okay? And this is basically what the computer system understand. Okay, I hope it is clear. So now we also have another numbering system that we call the hexadecimal numbering system. We also call it the base 16, which is made of values from 0, 1, 2, 3, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. But when we get to 9, okay, after 9 we have 10, 11, 12, 13, 14, and 15. But now those 10 here is represented by A, 11 here is represented by B, C here is represented by 12, D here is represented by 13, E here is what, 14, and F here is what, is 15. Are you okay? So the hexadecimal numbering system, okay, is made of letters and numbers. So you can see that here at the beginning we have numbers from 0 to 9, and we have what, letters that follows. Okay, but now A here, when you get to 9, okay, and then we have 10, 11, 12, 13, 14, and 15. But 10 here is represented by A, 11 is represented by B, 12 is represented by C, 13 is represented by D, 14 is represented by E, 15 is represented by F. Are you okay? So, and then this is what, and if you count, you can see that here we have 16, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 value in the hexadecimal numbering system. That's why we used to call it base 10 or base 16, sorry. Okay, so now let us talk about this. So this one here is not a numbering system, but it's something that you have to know. So we have what we call a byte or a octet. Okay, so a byte or an octet is a combination of 8 different bits. So we know what is the bit. Okay, so the bit basically is the most basic or smallest unit of information that a computer can process or understand. But how those bits are represented? Those bits are represented by 0 and 1. Please mute your mic, because sometimes when your mic is unmuted, I'll be listening to myself again. Okay, thank you. So now where was I? Byte or octet. So it's a combination of 8 different bits. Okay, so a bit here is the most basic unit or smallest unit of information that a computer can understand, can process or store, and it is represented by 0 or 1. So the 0 or 1 here, the 0 here, and the 1 here, they are what we call bits. Okay, but now a combination of the 8 bits here make up what we call a byte or octet. So if you have a combination of 8 bits like this, for instance 1 1 1 1 4 1 1 1 1 4, that makes what, 8. So a combination of 8, so 1 here is a bit, so a combination of 8 bits here like this, we'll call it what, octet or byte. Okay, so we can have another combination like this, for instance 1 0 1 1 0 0 0 0. This also 8 bits, but this combination of 8 bits like this, we call it what, a byte or a octet. Are we okay? So now down here I said what, that computers only understand binary, which is made of 0 and 1, and 0 and 1 are called bits. I hope it is clear. Okay, so let us move. So now that we talked about that, okay, let us come back to the addresses that I was talking about. So you can read here, I said what, so when devices in a network want to exchange information, they need addresses. The purpose of those addresses is to help devices in a network to locate each other and also to identify each other, the devices in a network. So there are two types of addresses used by devices in a network in order to be able to exchange information with the right device in a network. Because devices don't want to send messages to a wrong destination, that is why they need those addresses in order to be sure that they are exchanging messages with the right device. That's the reason why that devices need addresses. So now, what are those addresses? So there are two types of addresses used in a network. Okay, so the first type is what we call the physical address. Okay, and the physical address is what we call the MAC address or a burned in address. And the second one is what we call the IP address. Okay, IP address, and IP here stands for internet. Okay, internet protocol. Okay, and MAC address here stands for media access control. I think I've written it here. Okay, we talked about it. So MAC address here stands for media access. MAC stands for media access control. I've written it here. Okay, so those are the different types of addresses that are used by devices in the network. So we have the physical address. Okay, so we have the physical address which is the MAC address. We have the physical address and the logical address. Physical address is a MAC address or burn-in address, and the logical address is what you call the IP address. So now, what is a physical address? What is that physical address that I'm talking about? Let us move. Okay, so now let us move. Okay, physical address. So a physical address, as I said, is a MAC address, but MAC here stands for Media Access Control Address. Okay, so a Media Access Control Address is a globally unique identifier, okay, that is assigned to a device. Okay, also this address is uniquely identify a device on Earth. Okay, it is a burned-in or hard-coded on a network interface card of a device. Okay, so now when let's say vendors or makers or manufacturers create devices such as laptops, such as computers and everything. Okay, so those computers, when they create them, okay, they will also let's say that we have a computer like this. Okay, and when they will create a computer, that computer, okay, will come with what we call a network interface card. Okay, a network interface card. That network interface card is, for instance, the interface that will give the possibility to the laptop or the device to get access to a network, to have access to a network. Because the network interface card here, this is where we will find a port that we call a RJ45 port. Okay, so the network port is found on the network interface card. Are we okay? But now on that network interface card will be hard-coded an address that we call a MAC address, and that MAC address that will be hard-coded on that network interface card is there for the purpose of identifying this laptop uniquely in the whole world. Okay, so meaning that the MAC address that will be assigned to the network interface card of this device will be the unique one. There is we cannot find another device which is having the same MAC address. Are you okay? So the MAC address here, they are unique addresses. They are addresses that are unique in the whole world. So when a device has a MAC address, okay, that address is unique for that device only. And that MAC address, okay, is hard-coded or burned in. Okay, here I wanted to say burned. Okay, burned in or hard-coded on the network interface card here. So now I don't know if you ever come across a network interface card, but let me show you one. Okay, let me show you what is a network interface card. Okay, let me just show you. Okay, let me go to images. Okay, so this is a network interface card. This, okay, this is what we call a network interface card. This component that you can see is what you call a network interface card. And on this network interface card, okay, I don't know if we can see it on this one, but somewhere here there's an address which is hard coded on this card. I don't know if you can see it. Let me check. Okay, let us check. Let me check. Okay, on this network interface card, okay, we have an address which is the MAC address which is hard coded on this interface card. Okay, so now I'm looking for it. I don't know if it is this one here. Okay, it looks like this is the one that I'm talking about, this one which is here. I don't know if you can see. I don't know if it is this one, but I can count 1 2 3 4 5 6 7 8 9 10 11, but it is 12 characters. Okay, okay, well, so most of the time we will find it on the network interface card. It is hard coded on it. Okay, but there's two ways of finding that MAC address information on the network interface card. The first method is just to look at, I mean, you can open your laptop, look for the component for the network interface card, and look on the network interface card where they have hard coded, or they have written, they wrote what the MAC address information. Okay, but now let me try another one. Let me see if I can get another one which is having the MAC address information. Okay, let me network interface card with okay. Okay, just a minute. Okay, you can see that on this one here, wait, I don't know if you can see, but you can see on this one here, the MAC address is here. This is the MAC address. So this is a network interface card, but you can see that here they say the MAC address. The MAC address is just here. It is hard coded to the network interface card, and it is written here. This is the MAC address which is here. 1 2 3 4 5 6 7 8 9 10 11 12, and this is it. Okay, so a MAC address is an address which is 12, which has 12 characters. That's the characters that I'm counting like this. There are 12 characters in a MAC address. Okay, so this is basically the MAC address which is here. Okay, that is the first way to look at it. Okay, I mean to find out what is the MAC address on the network interface card. So the other way that you can use in order to find the MAC address of the network interface card, for instance on your laptop, okay, so you physically, this is how you can get it, but you can also look at you can also make use of what we call the command prompt in order to see the MAC address information in software. So now what you can do, you can go in your CMG, you go on the search bar here, you type CMG. Okay, CMG, which stands for command prompt. Okay, you press enter, you'll be redirected in your command prompt. Okay, and then from now you just input the command IP config slash, the command IP config slash all, and you press enter. Okay, so right now I'm connected to I'm using my wireless network interface card. Okay, that one too I will explain. So let me explain. So I'm saying that I was talking about the network interface card, but when it comes to the network interface card, we have it in two types. Okay, we have two different types of network interface card. We have the wired network interface card, and we have the wireless network interface card. So the wired network interface card is the one that you have on your laptop, okay, where we have a RJ45 port, okay, and then over there you in order to connect to a specific network, you will take an Ethernet cable and connect it to that RJ45 port, okay, and you will be able to have access to the network using a wire, okay. And now at that time you will be using of your wired network interface card. But now when you are using your laptop and you are connected to your Wi-Fi network, you are making use of the wireless network interface card. Are you okay? And the wireless network interface card also has a MAC address. So now on laptops or desktop, we have, okay, those who support Wi-Fi capabilities, we have two different types of network interface cards. Okay, we have the wired one and the wireless one. So right now I'm connected to my wireless network, okay, to my Wi-Fi network. So I'm making use of my wireless network interface card, and that wireless network interface card has a MAC address. And what is that MAC address? The MAC address, okay, this is my wireless network interface card. You can read here, wireless LAN adapter, which is the wireless network interface card, and down here I have what we call the physical address. I don't know if you can see, okay. Right here I have the physical address, and the physical address of my wireless network interface card is 24FD52769A and A1. You can see how it is represented, and this is what the MAC address. Okay, so you can count here we have 1 2 3 4 5 6 7 8 9 10 11 12 characters in the MAC address. Are we okay? So this is a MAC address. So now when it comes to the MAC address, as I said, the MAC address is written in hexadecimal. Okay, the MAC address, as you can see, is made of letters and numbers. Okay, a MAC address is written in hexadecimal, and the hexadecimal numbering system make use of numbers and